Hello friends, I am Vijan Velivare. All are welcome to my YouTube channel. In my previous video, that is video 27 on railways, we have discussed the daily patrol by keyman. In fact, this keyman patrol is one among the other 6 patrols conducted by engineering department. In this video, we are going to see how and when other patrols are undertaken by engineering department. Also, we will have a fair idea on this deep screening, thick webbed switch, and also the pulling back creep. Okay, the gang patrol will be introduced during heavy thunderstorm or heavy rainfall, unexpected heavy rainfall. In such cases, in such a situation, there is a likelihood of flooding of the bridges and causeways, and also there is a likelihood of breaching of the railway track. So in such a situation, this gang patrol will be introduced by the gangmate. He will utilize the entire trackman at his disposal, and they will be sent for patrolling the track. So that is gang patrol. Now let us come to monsoon patrol. The monsoon patrol is normally conducted during night. Hence, normally this monsoon patrol is called night patrol. In monsoon patrolling, it is normally introduced during monsoon period, and this will be introduced by the DE, that is divisional engineer. We will call also DEN of the division. He will be introducing this monsoon patrolling, and he will be deciding the period for which this monsoon patrolling should be in force. That is from this date to this date. That will be decided by DE. However, section engineer PA is empowered to advance this monsoon patrolling, as well as he can prolong the monsoon patrolling after the period prescribed by this DE. Prior to this monsoon patrolling, DE will supply patrol chart to all stations coming under the section, and also the controllers. The patrol chart will clearly describe from where the patrol is to be commenced from that station, and where he must take rest, then again where he must go. All these details will be given in the patrol chart. Suppose the section between the station A and station B is coming under this monsoon patrolling. Both these stations will be issued with the patrol chart, and also section engineer PY will give a list of the trackmen who are going to be employed in patrolman duty. So that list, their name, address will be given to the station master by the section engineer PY. Only those trackmen who are very healthy and also very sincere will be employed in the patrolman duty, and these patrolmen will undergo medical test before taking up the duty. This patrolman will have a beat book with him, and in this beat book he must get the signature of the station from where he is commencing this patrol. Normally one patrolman will be employed for the duty at a time, but if CTE permits, one more patrolman can be employed at the same time. That is, 2 patrolmen will be patrolling the section, especially during night and in guard section, etc. So employing additional patrolmen will be decided by CTE. Now the patrolman, he will report to station master A for patrolling duty. At that time, the station master must sign in the beat book. Every patrolman will be having a beat book in which station master must write the date, time, the name of the patrolman going for this duty, and put his signature. Also, when the patrolman returns after the patrolling, again SM must write all these details in the beat book, and also in the remarks column of the TSR about the arrival of the patrolman. The patrolman having a backpack in which all the equipments will be there for patrolling the section. In that backpack, there will be a small tin containing 10 detonators. These detonators he must use to stop the train in case of emergency. Suppose there is a breach, or suppose the train should not be moved along that section, he must protect that train using these detonators, as in the case of keyman. In the bridges, if the water flows above the danger level, and in the causeway, if the flat bar is already drowned in water, in all such cases, wherever there is dangerous condition, to stop the train, he must use these detonators to stop the train. When the patrolman comes to the station for getting the signature of this station master for starting the beach, SM must see that he is having all the equipments with him. Suppose there is shortage of equipments, this should be reported to DSO by the SM. SM must report the shortage to DSO, and he must wait for the direction from DSO to what to do with the patrolling. For the purpose of undertaking patrolling, the section between two block stations will be declared as a beat section. A beat section should be within 10 kilometers. Suppose it is above 10 kilometers, any flag station or CNC station in between these two block stations will be decided or declared as an intermediate beat station. So these block stations will be called beat stations, and the section will be called beat section. This beat section is further divided into beat length. Beat length will be normally 5 kilometers, not above 5 kilometers. Suppose let us take here the station A and B, it is 10 kilometers. Then here the patrolman from A station will walk towards this direction. He will walk around 5 kilometers. By the time another patrolman from B station will come towards here, and they will exchange the beat books. Both are having beat books, they will exchange the beat books. After that, the patrolman from here, he will return to this station B, and also the patrolman who came here from A station will return to his station. So altogether he will be walking 5 plus 5, 10 kilometers at a time. When he reached here after walking 5 kilometers, he can take 30 minutes rest at this spot. Maybe a flag station or a CNC station may be there. So there he can take 30 minutes rest before commencing the return journey. Now he has completed 10 kilometers. Then after taking 3 hours rest, minimum 3 hours rest, he must patrol the section again. So again he will walk 5 kilometers and exchange the book and return to the station A. So altogether he will be walking 20 kilometers. So a patrolman, he should not be employed to walk more than 20 kilometers in a night. The walking speed of patrolman is 3 kmph. Patrolman is supposed to report at 21:30. At night 21:30 the patrolman must report to the station master A, but he does not report at that time. Then what the SM has to do? He must wait for 15 minutes. He can wait for 15 minutes, and if the patrolman does not report, means he must issue caution order to all trains. Also he must contact the station master at B, and he must also issue caution order to all trains coming towards this down direction. So for up directions he will be issuing caution order. For down direction, station master B will be issuing caution order. So this caution order speed is, during night it is 15 kmph and during day it is 40 kmph. So these caution orders should be issued till it is confirmed that there is nothing wrong with the track. Section engineer PA must inspect the beat book once in a week. The section engineer PA must conduct trolley inspection of this section during the patrol period at least once in a month. Now the next patrol is hot bar cold weather patrol. Hot bar cold weather patrol. This patrolling is introduced when there is extreme hot, that is especially during the peak of summer. This hot weather patrol will be introduced. What will happen during this peak of the summer? Due to the sun heat, the rails will expand. You know the rails are made of iron, and this will expand during the hot weather. And during expansion, what will happen? During expansion, here at the SCJ, the rail will expand more than the gap given. Here there is a gap given on either side for expanding the rail, but if there is extreme heat, then there is a chance that this rail will expand more than the gap given there. In that case, there is a chance of this bending of this rail, and it is dangerous to the train. So during hot weather patrolling, the patrolman should see that SCJ is not affected by this extreme heat. And also there is another problem, another two problems, that is buckling and kinking. During buckling, what happens is, here you can see the rail has shifted laterally due to extreme heat. Due to the expansion of the rail, it has bent towards inside. So this is a lateral shifting. This is called buckling, and this happens during extreme heat. Patrolman has to see that there is no lateral shift for the track. During kinking, what happens is the rails go like this. That is, it goes in a zigzag way. And this also to be ensured during hot weather patrolling by the patrolman. During cold weather, what happens? The rails will normally shrink. When it is shrinking, what happens? LWR is long well rail. This welding will give up. This welding will break because of the shrinking of the rails. Gap given for expansion, that will widen, that will go more. That is dangerous for the train wheels. So during cold weather patrolling, especially the patrolman will see that there is no weld failure, and also the SCJ is in good condition. Watchman at vulnerable places. When there is heavy rain at this section, certain causeways or bridges getting always affected. Here in these places, watchmen will be posted to see that the bridge is not affected by this flood, and also causeway, the water is not rising to a dangerous level. Then there is the sixth one, that is security patrolling. Security patrolling will be introduced when there is agitation against railways, or when there is a threat from antisocial elements. So when there is a threat that the track will be sabotaged, or when there is a threat that stations will be attacked, in that case security patrolling will be introduced by the engineering department. Now let us come to two major maintenance work undertaken by engineering department. Deep screening work and pulling back creep are two major works undertaken by engineering department. Deep screening, I think I have already explained it in the session 22 video on this track machine working. That is, the track is laid on a bed of ballast, and the ballast is loose, and this loose ballast gives a cushioning effect to the train. So when the train is moving over the track used to go up and down, and so the travel will be very comfortable. Due to the continuous movement of the train, and also the dust and also silting, etc., this ballast bed will become rock-like. It will act like a single piece. So this cushioning effect will be eventually lost. In such a condition, in such a situation, what is to be done? Ballast underneath these sleepers to be removed, cleaned, and it must be thrust back. So previously this had been done by the contract workers, but now we are doing with the machines. For the ballast cleaning, we are using ballast cleaning machine. Then collecting the ballast towards this rail, we are using BRM, and for tamping in the ballast or pushing in the ballast, we use TTMs, tight tamping machines. So that is Unimat or Duomatic. These machines are used to tamping back the ballast underneath the sleepers. So that is how it is deep screening work is undertaken. For this deep screening and as well as for pulling back creep, caution orders will be issued by the station. Now let us see what is meant by this pulling back creep. When the wheel is moving towards this side, towards forward, the wheel will be exerting pressure towards back, towards this side. Wheel will be moving towards this. So the rail will be pushed back. You see, while walking on a floor, what we are doing? We are pushing the floor back, or we are exerting pressure towards the back of this floor so that we will get a forward momentum. Suppose we are walking along the seashore, we cannot walk easily in the seashore because in the sand it is not possible to exert pressure backwards because it is loose sand. So it will be difficult. We will not get that momentum to move forward. So that is how normally the movement is happening. Here in this double line, the trains are moving always on this side, and in the down line trains are moving always towards this side. So when the trains are moving always on this side towards the up direction, what happens? The wheels of the train always moving in the forward direction. In that case, the rail will be pushed backward. And this backward movement of the rail will be very minute, and so only after a long time it will be felt that the rail has moved back. This backward movement of rail is called creeping. So here what will happen when the rail is moving backward? What will happen to this SEJ? SEJ, the gap will widen. Here the gap will widen because the rail has moved backward. So in this case, you see this joint. Here the joint is supported on two sleepers. Almost equidistant the joint is kept. When the rail is moving backward, the support to the joint will be lost, and there is a chance that this joint, the rail at the joint, will move up and down, and eventually it may lead to some breakage or even derailment. These are the two problems arising out of the creeping of rails. In order to rectify this, what will be done? This rail, which has been pushed backward by this continuous movement of the wheels towards forward, when the creep is beyond the manageable level, what will be done by the trackman? They will pull back the rail. That pulling back the rail to its original position is called pulling back creep. Okay, in my previous video, I have mentioned about this TWS. TWS is thick webbed switch. I hadn't explained what is TWS. How this TWS is different from the normal switch. This thick webbed switch and the normal switch, what is the difference actually? We just examine the what is called cross section of a rail. The rail will be having a top portion like this, then there is a thin portion like this, and here this is called head of the rail, and here is the foot of the rail, and this foot is fixed on the sleepers using the panroll clips that you know. Then connecting this head and foot, there is a thin portion, and this is called web of the rail. So this is the cross section. It is on this head the wheel will be moving. So now let us see. Here you see the picture. Here you can see this is this arrow. I am showing this arrow, red arrow. That red arrow is showing the toe of the switch or toe of the tongue rail. In this side, here it is the toe of the tongue rail. But you can see there is an extension of this web portion up to here. And it is here in this end, the rods controlling the movement of the switch is fixed. And you can see here the ordinary switch. In this case of ordinary point, you can see the tongue rail ending sharply. There is no extension. There is no extension. Whereas in this case, we can see there is an extension of this web portion. And this is giving much strength to this tongue rail. By having this TWS, we can increase the speed of the train in the turnout. In the turnout speed, already I told you 1 in 8.5 turnout, it is 15 kmph, and 1 in 12 turnout, it is 30 kmph. But by providing a thick webbed switch at 1 in 12 turnout, the speed can be increased to 50 kmph. So by providing thick webbed switch at 1 in 12 turnout, we can increase the speed of the turnout from 30 to up to 50. Okay, that is the benefit of having this thick webbed switch. Then Here, instead of this structure bar, an instrument called SSD is provided. You can see this is what is called SSD. Here it is the SSD in open condition. So this SSD is spring setting device. So spring setting device is provided at a thick webbed switch. By having this spring setting device, it is possible to move the tongue rails separately. So this much about the TWS. Now you have got a fair idea on the permanent way and the works undertaken by this engineering department. In my earlier videos, I have mentioned about the other works also undertaken by this engineering department. Anyhow, we will come out with another video on this permanent way later. Okay.